Very good evening, students. Very warm welcome.
Good
Very
evening,
happy
sir.
to see everyone on time. Still waiting for a couple of more students.
Good evening, sir.
Give them a minute or two. Very good evening, everyone. So we have six of us. Rita, Sandeep are not here. Nukul is here. Karishma is not here. Prerit is not here. Sita, Gulshan, Chaitanya, Muskan. Vishnupriya and Suchita. Okay. So students, I hope you have revised petrostatic systems. And when you revise petrostatic systems, of course, you're supposed to revise altimeter, VSI, ASI also, because it's all interrelated. And I'll be giving you all a test on air data instruments soon, anytime as a surprise. It could come today, it could come tomorrow, anytime. Like, be prepared for these topics. These are hot topics for you to revise so that we can discuss if you have any other pending doubts, because could be confusing, right? I've asked many students to give me a list of topics of their concern. I'm getting it from some students, but I'm not getting it from all students. So I'll assume that you're not having anything, or if you're having anything, then you'll be sharing it as we go ahead. So remember that as well. Just checking. We will start the session. If you have any doubts, we'll start the session asking your doubts, clearing your doubts. Let's go ahead and see if you have any questions with respect to anything done so far. TSI, AH, 1/60, VR, DME tracking, so much. With respect to the questions, in TSI also I have something to discuss. But fine. No problem. We will get started. And whoever is late, we'll ask them to just cover up what can be done. So students, today there's one interesting topic that we're going to study. A very easy topic, couple of questions on the topic can be expected to come. I have it. I have it. Don't worry. I'm just checking. So the question that you had got for TSI, I'll quickly see what these doubts are. What is the code for the test? I think it's 4K23. Let me cross check. What heading do you stop the turn? So students, these questions are turning error based questions where what happens is it under reading, over reading. If it's over reading, then you should turn out quickly. If it is under reading, then you should turn out later. Now here, question number 2, the options are 240, 255, 235, 205. What is southeast to southwest? Southwest is 235 degrees. Okay, 215 degrees. 18, I think 225 is southwest. So Near to 225 will be the answer. It can be 235, 205 also. It depends upon whether you underread or overread. Try to find answers with respect to this. They're also talking about rate 2 turn. What is rate 2 turn? We know rate 1 turn, rate 2 turn. So rate 2 turn will be. So this question is somewhere related to your turning error AH. So accordingly, it underreads or overread through 180 degrees. If it overreads, then you will turn out quickly. The answer will be 205. If it underreads, then the answer would be, it will be rolled out later. The answer will be a higher one, which could be 235. Now, what are the correct answers? Here, see, I can show you how to find the answer, students. It is not that difficult. Here, if you see the correct answer you have been marked is 255. And many students who have got 255 have got it as a correct answer. Now, why 255? Of course, it might be under reading, it might be over reading. With respect to that, I will level out the turn, or when, on what heading do you stop the turn? Students, for this, try to recollect your compass-based turning errors and try to recollect what do you do in the session, when do you roll out. That is very tricky. Students getting 235, 205, I can see a basic error is made. But students getting 255 as the correct answer, well, I would want to see how you have solved it and with reference to what. So Muskan, what's your confusion in this question number 2?
Sir, actually, I didn't get that question. But now, when you say that it is related to compass, so I remember now. What is that?
Not just compass, but yeah, similar to that. You roll out sooner, you roll out later. That is the meaning of this question. On what heading do you stop the turn? On what heading do you level out the aircraft? On what heading do you stop? And rate to turn, who can tell me what is rate to turn?
360 degree in one.
360.
Yeah, Nukul? Nukul, you were giving me the first answer.
Sir, 360 degree in 1 minute.
360-degree turn in 1 minute.
In
Very
1
good.
minute.
So the keywords, students, these are trick questions. If you can learn to solve them, then probably you'll get it right and can be useful. Try to see if you can get it. You have information given to you with respect to turning errors in AH also. Try to compare your answers with these and see what do you get. A quick 5-10 minute research is more than enough. Students have got 255. How have you got 255? Have you got 255 just because you had practiced it in the textbook and memorized? You have memorized the answer? Or have you solved it logically? So that is something that you should think about. Second question, question number 3. An aircraft is flying a true track of 360 from 5 degrees south to 5 degrees north. What is the average apparent wander rate? Students, basic gyro. Basic gyro, go to the text and find out how to find this answer. I can see students saying 0 degrees, +5, -5 degrees per hour, depends upon ground speed. Good guesses. Some of you all have got it right also. But if it is not directly taught to us, how do we get the information? We try to track it down quickly. And whether we get an answer or not is my expectation for you to share with me. Saying, sir, I've researched basic gyro, wander, apparent wander, the rates are given to us. 15 degrees per hour is something that we have. That is with respect to certain positions from one hemisphere to another hemisphere. That's it. That's how you revise. That's how you do a final revision and a final doubt solution. So question number 3, again, apparent wander rate is something we should look into. And once we have looked into, then we'll get back. So Muskan, you'd get back, or if you have looked into it, then you'll tell me, okay, you have looked into it, but not got the correct answer, how to do it. Students, what is wander? Wander, drift. It is just an error in the indication because of the deviation in the axis of the rotor of the gyro. It happens due to earth rate, It happens because of so many reasons when we are aligned. What happens? These gyros, they first align with the local north, with the local true north, and then they begin some of the gyros. But when we go from point A to point B, the local north of point B will change with respect to the aircraft. And so the value of the drift or the wander or anything could also change. Because here the true track is of 360 degrees, the track is north, so the plane is flying north, it's not crossing. It is not crossing any longitude. It is going from 5 degrees south latitude to 5 degree north latitude. So it's maintaining the same meridian. Because it's maintaining the same meridian, they are saying 0 degree per hour is the apparent wander because the meridian has not been changed. This could be a way of explanation for this. But I would want you to just quickly read and see if you recollect how wander is measured. 3, 4 complicated paragraphs, but quick read with key points is what I'm expecting you all to do. Here, because my track is just the north is the track from one lat to another lat, I can say my wander is 0 because my alignment of a gyro axis can be considered with the local north, and my north is just not changing here because I'm just traveling northbound. So my wander is 0. If I would have traveled one lat to another, one longitude to another longitude, then probably I would have got some error. This is all that comes to me right now when I'm thinking about it. As a student, with respect to the exercise, I have to just look at the notes and just see and do my final revision there, along with getting an answer. Students, we are discussing a couple of doubts from your TSI test, question number 2, 3. Question number 4, an aircraft turns right through 0980. So it's turning through east onto north. Okay, so it is going from east to north. It is going that way at 48 degree north using a direct indicating compass. The aircraft is turning at rate 2. What heading should the aircraft roll out? Students, simple. You are turning through east to north, through easterly turn going towards the north side. This is the turn. It's a compass. It's a rate 2 turn. When will you roll it out? At what point? So that's the case here, students. Overread, underread again. So we have to go through that part and revise it carefully. That's all that we need to do. And question number 6. Muskan, I'm giving you hints. Once you try, post that, you can get back to me. Which instrument has 2 degree rotation in the horizontal axis? What's the doubt in this question, Muskan? Which instrument has a 2 degree rotation in the horizontal axis? Directional gyro, maximum students have got it wrong. Turn indicator, maximum students have got it wrong. 3 students were able to mark it correctly, which was artificial horizon.
Sir,
Mhm.
sir, I got confused because it is vertical axis or gyro. That's why.
Students, don't do that mistake with gyros where you just look at key point, vertical, horizontal, and answer. Sometimes you will get confused there. Because I remember one doubt I got in the morning. Somebody was asking, sir, is TSI horizontal axis gyro or vertical axis gyro? The horizontal axis gyro. But in one of the points in the brief, it's mentioned that, what do we say? It is mentioned that it measures the turn of an aircraft about the vertical axis. They mentioned that it measures turn about the vertical axis. It's a horizontal axis gyro. So we did not worry that why are 2 axes mentioned here? Okay, it measures the turn about the axis, right or left of the vertical axis. The turnings are, so what is this vertical axis turn basically? My vertical axis goes like this up and my turn is like this about the vertical axis. My turns are always about the vertical axis. Around the vertical axis is what they mean. It doesn't mean the gyro is vertical axis gyro. The gyro will be an horizontal axis gyro only. So do not get confused like this. This is another example of getting confused unnecessarily. So 2-degree rotation in the horizontal axis, 2-degree freedom, horizon, artificial horizon is the correct answer in this case. See, I'm confusing y'all with gyros, mixing couple of questions here and there. It is important. Students, I want you all to revise directional gyro and be ready so that a consolidated gyro will be done as we go ahead. Students who don't have lecture numbers, lecture references, who are still oblivious to things, please get in touch with me. Sandeep, I don't understand why you're late. It's okay, but I'm waiting for you since 20 minutes because the same issue had happened, Sandeep, for your 1/60 also, for AH also. Because you're not able to maintain time, your doubts are pending as everybody's doubts are cleared. And we don't have the bandwidth to do the same thing twice again and again. So students, it is very important that now on, that exams are very close. Now on, you stick to time or else then you go through the recorded session. One or the two, because I can be late. That is understood because nobody else is missing something. You can revise. I've given you instructions. I'll give you further instructions. But when even one student is late, the whole plan will be because what to do then? एक के बिना मैं कैसे कर लूँ जब उसका भी ज़्यादा ज़रूरी है clear करना doubts. And then you're not informing me also, students. I understand one off it's fine, but sometimes it's not fine. I give you a lot of freedom, students. But please be careful about it, okay? No worries, but still be careful. Otherwise, what's the point then? You know, we won't have time to do everything twice or thrice, is what I'm trying to say. So please
I'm sorry
be
for the late,
careful.
and I'll make sure it won't happen.
No,
And
Sandeep, it's okay. You don't have to respond. Stand by. Relax. I'm talking to everyone, not just you. Gulshan is late. Even Suchita had disconnection. Even Prerit is late. Because you're new, I'm sharing directly with you, but this is for everyone. Sandeep, in your case, that's the only problem that you're not there when the doubts are resolved. That's why your doubts are pending. But it's okay. You're getting used to it. I'm just keeping you up to date. It's okay. Don't worry. I know everybody's individual situation. So don't worry about it. We have already discussed couple of points about question number 2, 3, 4, and 6, how to do it. So anybody who's yet to resolve, you will go through this part of the session. Once the session is over quickly, started at 12:35, 15 minutes from there. Okay. 10 minutes, I think 35, 40, and 50. Yeah. 15 minutes only. You've not missed much. Only explanation of question numbers 2, 3, 4, and 6. Okay. For test on TSI. Remember, I'm quickly discussing other doubts, students. If you have anything, quickly bring it to my notice for TSI. Sandeep, I'm checking your doubts now. Which were the question numbers? You have not mentioned the question numbers. Can you quickly mention the question numbers, Sandeep? 6 to 7 questions, right? So question number
sure, sir, one second.
3, question number 2, 3, 4, 6. Apart from that, what are the other questions? Quickly give me a number of those questions. Also, students, the question with respect to in a left turn while taxing, question number 7. Now, this is a very basic question which could be answered. Now, the other questions that Muskan was asking, probably you need to read a little bit again about wander, about turns before you can come up with the correct answer. Question number 7. In a left turn while taxing, the correct indications are. Now, very simple. When you're taking a left turn, you're yawing on ground during taxi. In air, when you're taking a left turn, you're yawing, that is using the rudder. In air, in a left turn, you're also banking to the left. On ground, you're not banking to the left. Now, what indication do you get when you are turning left, when your rudder is adequate, but your bank angle is less? Because when taxing, you're not banking at all. So the correct answer will come with respect to the situation of the instrument indication where bank angle is less, not enough. So what indication do you get? Needle is left, but ball is right. So that becomes the correct answer while taxing. Interesting, right? Now in taxing, the roll is 0. The bank is 0. Turn will always be in the direction of turn, but the bank angle will be 0. So what happens when your bank angle is 0? Yes, students, try to recollect TSI notes. What happens when the bank angle is 0 or less, not adequate? The ball, is it in the direction or is it in the outside direction? Simple. The ball could be left, ball could be right. Definitely not in the center. A ball is in the center of the inclinometer only when the turn is balanced. Are you following, students? Sandeep, waiting for you. Students acknowledge yes, no, maybe. I'm not sure you're following, not following. And students who don't have doubts, you have to listen, okay? It should not be like, otherwise, you will miss out something important that I'm saying in between, right? And Sandeep, don't worry, don't take it personally, okay? I'm just sharing it with everyone, and that's my job. I know all our issues, we all have issues, so I respect that. But when I know that people are going to be on time and then they're not on time, that's when I'm saying like, okay, you're just confirmed, like pray that confirmed, but you're not there. Why? You could have told me. It's okay, but not a big deal. Just make sure that we try to not miss things. Taxing,
Sure, sir.
TSI, taxing and TSI, okay, easy. We have another doubt for question number 14. Sandeep, more questions, please tell me, okay, quickly. To obtain heading information from a gyro stabilized platform, the gyros should have. Now, students, this question comes from directional gyro. Okay. I need heading. How do I get answer? Now, directional gyro is advance of, it's an advancement, you could say, of your compass. Your compass, your magnetic compass will not give you accurate readings, but a directional gyro can give you accurate readings because the directional gyro is based upon the compass, but it will not have the compass acceleration and turning errors. Now, for a directional gyro, we need to know a little bit of theory. If we don't know, you put it in your parking lot. I'll share a lecture with you. You study that. All the answers will be directly, and you'll also understand that. 1 degree of freedom and a horizontal axis. It's a horizontal axis, 1 degree freedom gyro. Basically, horizontal axis, how is the gyro mounted on the axis? So basic gyro revision, students, if you have not done, put it in the parking lot. Let me know. I'll give you lectures, you study, and then you'll be in much more better position to give answers. Horizontal axis, 1 degree freedom, DGI, basic, students. Why horizontal axis? Because directions are measured horizontally. 1 degree of freedom is enough because it measures angular measurement. So DGI is a displacement gyro. It's aligned with 1, and then we measure the displacement to measure the directional value. Okay, a brief point discussed, you put it in the parking lot or to read or to study. To read, then go through the text. To study, then go through the lecture. Parked as in to discuss doubt. These are the 3 ways you have to understand things right now. Take your time. Then we have one more question, question number 20. Yes, Sandeep, what's your question?
Sir, now I understood the 14th question. It's just that, I was not expecting this question to be in this turn and slip test. I was expecting that to be, the DGI only when it was saying that heading information from gyro. Then I thought it's 1 degree and the vertical axis, the horizontal axis. But yeah, now it is cleared.
Students, I was just saying that I will be giving you, I have given you basic gyro also and gyro based questions here and there also in topic wise gyro also, topics that you've already covered. Probably, Sandeep, you might not have studied DGI. That's why, but it's okay. You give the test, students topic wise. If I tell you it's topic wise, so you're focused and learning, but The basics and fundamentals, based upon that, be ready to give answers. If you don't know the answer, then you will know it once you solve and decide. So both ways, it's a win-win situation for you all. Don't assume, students, anything. Don't think, just research. You have that ability right now. These are practice tests. If you use the strategy carefully, students, everyone, trust me, your study will be wholesome. If you listen to my instructions and do as I am telling you to do, trust me, it will be very wholesome. If you're thinking of not doing it, and if you're thinking of doing something else, then please at least let me know. Otherwise, I'll be expecting something else, and because of what you are doing, we might not get that result. And you might also be expecting what I'm expecting. But if you're doing something else, then there will be a big issue by the time results come, right? This is for everyone, students, everyone. Next question is 20. If the filter of a air-driven rate of turn indicator becomes partially blocked, students, clearly done in theory, this very clearly done. The answer should be very easy, but still I see 40% of students have given wrong answer, 60% have given correct answer. When it is blocked, students, the vacuum flow is reduced. And the force produced, and if you look at the option, generally we can say if the filter is blocked, then we will get the under-reading, over-reading things, overspeeding or under-speeding. And what happens when the gyro is overspeeding? What happens when the gyro is under-speeding? But when we look at the options, what do we get? We see the calibrated spring is exerting a force about the lateral axis equal to the rate of the turn. Is the statement true? The force produced by the spring is producing a precession equal but opposite to the rate of turn. Students, give me a second to cross-check this question, okay? I think there could be something. Question number 20. Number 20. Just a second, okay? Mm, 37. Question number 20. Okay. Just stand by 1 second. Muskan, what's your observation? Question number 20.
Sir, the correct answer is delta.
What's your observation there?
Sir, related to this question, you have
Suchita, how about you? Question number 20.
sir, you explained this in theory
Mm-hmm.
related to spring.
Mm-hmm. Prerit, Gulshan.
So the spring provides the force, which produces precession, which is equal to the rate of turn, and also the primary precession and combined with the spring, that is the secondary precession. It gives an overall force that will tilt the gimbal, and the force will be generated.
Mm-hmm. I'm not very clear if I've understood what Suchita you have said, but yeah, it supplements to what Muskan was saying with respect to the point. Fine, wait. Input students, everyone in the class. Question number 20. What is the relationship with the filter of the gyro being blocked partially? And so see, we have a function. I'll read it out. Sandeep, be on the lookout. Everyone. If the, okay, where is it? Yeah. If the suction is inadequate at a high altitude or with a choked filter or a leaking suction tube with an air-driven instrument, gyro rigidity will be lowered as the gyro is underspeeding. Consequently, the secondary precession needed to equal the aircraft turn can be generated by a smaller secondary torque. This reduced torque will be produced by a smaller angle of gimbal tilt, and this means that the instrument will underread the turn rate. Now, this is something that we have seen about this point, effect of varying rotor speed. Is our answer anywhere related to it? Let's just think about it. Sandeep, are you doing it or am I the only one who's doing it? I want everybody to be involved in this. Don't just wait to get simple answers. We are researching something right now. You have to do it together and help. When I'm saying everybody in the class and when I see only 2 students responding, then I'm wondering what are other people doing? What is Vishnu Priya doing, Prerit doing, Chaitanya doing, Nukul doing, Gulshan doing? Only Sandeep, Muskan and Suchita are doing it. What about others? So I'm waiting. So let's compare. The spring is providing a force which produces a precession equal to the rate of turn. 1 second, okay. I am confused. I'm thinking probably what if... 1 second, okay. Muskan, what are you talking about explained in the class? Can you get me the reference? I'm unable to find it. Suchita, can you give me the reference?
Sir, in that lecture, you explain about that spring. Stand by.
It's fine. You're trying good. Spring is mentioned. I'm talking about the whole question. Chaitanya, are you looking at question number 20 or not?
Yes, sir, I am looking.
Prerit, Gulshan, are we looking at question number 20 or not? What's happening?
Yes,
What are you talking about it?
So my doubt was when attempting this question, I remember you clearly explained the steps. So the spring is providing a force which produces a precision equal to the rate of turn. So that I remember, but I was confused with the question here. If the filter of air-driven rate of turn, air-driven rate of turn indicator becomes partially blocked, that I don't remember. I mean, I am remembering the fourth D option as a principle of the air-driven uh, rate of turn, but I don't know what happens on the partially block. That is what confused me.
See, students, this is exactly the reason I'm asking is very silly. Okay. But nobody is focusing right now. And you only see what you're doing right now as a student. Okay. I'm asking you something again and again, which directly speaking is a error in the question and error in the answers. Okay? And that is the only reason why there is no explanation. Because the question and answer options are not linked with each other. Okay? They're not linked. So somebody telling me I have a doubt in question 20, I understand why. Because the question is wrong. But why only one student out of 10 students knows this? Why only Sandeep has a doubt on question number 20 and nobody else has a doubt on question number 20? That is the serious concern here. बार बार मैं बोल रहा हूँ, चीज करने बोल रहा हूँ, nobody is stating it out. They are saying, yes, we are doing something, but nobody is bothered, nobody cares. That's the truth. If that's the truth, then don't give me jazz when you give me jazz. Simple. Nukul, you're trying to say something. Please go ahead.
Sir, we differentiate two things, that is rotor speed less than required, and one is rotor speed more than required. So I've connected those points with this like partially blocked. So it comes under the rotor speed will be less. So we written down under the rotor speed less, the spring provide the force which produces precession equal to the rate of turn. So that's how I connected and given the right answer.
Good job, Nukul. Good thinking. Good thinking. Let me give you all the correct answer. अब आप लोग खुद ही खुद को देख लो students, who's more absent-minded, who's not absent-minded, who's focused, who's not focused, and who's doing how much and not doing how much, or who's just nodding the head in some or the other way. Okay? Every time when you come across something, it should not be too hard for us to be known, because you have the text, you have the material, and you have already read through the text to get the questions in the first place. It means you are not doing something or the other as you are asked to do. And it's a wake-up call for whoever is doing that. I'm not going to take names because I'm not sure who's doing it. I know, but I'm not sure, because I'm always trusting y'all. See, you have to study. There is no shortcut. How many times do I say that? If you are lazy, you don't want to study, and that's why you're becoming a pilot, then it's an illusion. It's a big illusion then. It's a wrong thing told to you and you're believing in the wrong thing. Simple. Now I'm giving you the correct options to that question and accordingly mark. As per that spring, the last option is correct. Don't worry, it's clearly explained. Yes. Here the question and the answers are a printing error. You are not to blame. But why I'm upset is because when I'm asking you to research, nobody is able to decipher that. How difficult is it? You go through the text, you go through the question, you know, sir, kuch nahi diya hai, sir, kuch to mistake hai. Haven't I taught this to you all, that learn to spot mistakes in questions also sometimes? Muskan is trying, Muskan didn't get it. Muskan, hardly 2 minutes, 1 minute, sir, nahi hai, kuch to gadbad hai wahan pe. Khatam. That should be our conclusion, students. That is a sign of confidence. Now I'm giving the same answer. Question number 20 question is this. If the filter of an air-driven rate of turn indicator becomes partially blocked, what will happen? Option A, the aircraft will turn faster than indicated. Option B, the instrument will overread. Option C, the rate of turn indicated will be unaffected. And option D, the radius of the turn will decrease. What do you think is the correct answer? The aircraft will turn
Alpha.
faster than indicated. Faster than indicated means overheat, right? The instrument, what is faster than indicated, students? This is also one point I wanted to discuss with you all. The aircraft will turn faster than indicated. What does it mean? Underread or overread? Who was giving me the answer, Alpha? Go ahead with your answer. Come on. Muskan, were you giving me the answer, or Vishnupriya, were you giving me the answer?
Underread.
Students, talk. Talk, talk, talk. I'm asking a question. So don't worry, relax.
So the aircraft will move faster as it is indicated by the instrument.
So the aircraft turn is more compared to the indicated turn on the instrument. It means the instrument is under reading. When the filter is blocked, the rotor is underspeeding. Underspeeding rotor, less rigidity. So the instrument will underread itself. Now the flow chart in my mind, the research in my mind is fixed. Now this is how I move ahead. This is the whole idea behind these exercises, students. You learn a little extra and you figure out some mistakes. Right now, complacency seems like a mistake here. Nobody noticed it. Nobody cared about it. Maybe nobody looked at the question. Maybe some of you all did, some of you all didn't. It's okay, but be alert from now on. So question number 20, the options in your tests are not for that question. Maybe somebody did an error while moderating the test. But why were you not able to spot it and put me or put them as a doubt? Why did you not say, sir, baki doubts ho gaye, ye doubt nahi hai? Why? It means you are lying. It means you are not doing as you are told. That's all I can say. I will wish for you for the good results only. But I want you all to prepare it that way. If you're not preparing, then I hope you have a better way to prepare that will guarantee better results. But you need to have a plan. And what was the last question? Was it 23 or 24? 23.
It's 23, sir. Sir,
Everybody got question number 20 resolved, understood. The options and questions are erratic. That's why you have got the wrong answer. Sandeep, stand by. The correct answer, aircraft will turn faster than indicated. Aircraft turns faster than indicated. Indicated is slower. Slower means under reading. In this case, slower, you can go ahead with the underspeeding also because the filter is blocked. Think about it, students. Things are specific. Sometimes you have to think out of the box, sometimes not. Okay, Sandeep, please tell me.
sir, so the correct question for these options would be, what is the principle of air-driven rate of turn indicator, right?
Sorry, say again.
What could be the correct question for those options that are already there? Like, it is, what is the principle? What is the secondary precision for the air-driven rate of turn, right? What is it? The question could be.
I'll change the question, okay? The question is, actually, some printing mistake has happened.
Yeah.
Everybody write down the question for question number 20. Either you change the question, you change the options. You change the question, write down the question. When the pointer of a rate of turn indicator, when the pointer of a rate of turn indicator shows a steady rate of turn. Students, can you see the screen? I'm not sure if you can. Okay, yes, you can. Great. I'll say the question again. When the pointer of a rate of turn indicator shows a steady rate of turn, a steady rate of turn. So they are basically talking about the basic functioning. So when we have a steady rate of turn, what is happening with respect to the spring? So the calibrated spring is exerting a force about the lateral axis and equal to the rate of turn. And then we have the force produced by the spring is producing a precession equal but to opposite to the rate of turn is correctly banked. The spring is providing a force which produces a precession equal to the rate of turn but in opposite direction. The spring is providing a force which produces a precession equal to the rate of turn in the correct direction. So the spring gives you secondary precession in the direction of turn. Remember that. Secondary precession in the direction of turn. Simple. So the first option, calibrated spring is exerting a force about the lateral axis equal to the rate of turn, doesn't make sense. Force produced by spring is producing a force equal but to opposite to the rate of turn. No. And the last is in the opposite direction and in the correct direction. So in the correct direction seems like the correct answer. The question is this: when the pointer of rate of turn indicator shows a steady rate of turn. And the next question, if the filter of a air-driven rate of turn indicator becomes partially blocked, I think that is question number 9. So 19. So two options were like two questions were the same. I think 19 and 20. Nobody noticed that also. Nobody was able to say that the 1920 questions are the same, but options are different. Even that is nobody able to point out. I'm just saying, students, you're not able to point out. I'm not judging anyone right now. I'm just saying that. I wonder why. That is something that I'm giving you a chance right now to figure out, but you're not doing it. I'm going through the text, trying to do so much at the same time to help you do it, to show you how to be done. Some of you all are trying, but what about others? Come on, yaar. Anybody who wants any question paper again and again in future to solve, let me know. I'll share it. Question number 23. The rate of turn indicator uses a rate gyro which spins up and away from the pilot. What's the doubt?
Sir, I didn't understand up and away from the pilot. What
संदीप
it is.
लेक्चर क्यों नहीं अटेंड किया अच्छे से? क्या फायदा लेक्चर अटेंड करने का फिर? सब कुछ तो बताया लेक्चर में ये सब. Who will explain up and away from the pilot? Please. Who can explain? Question number 23. Gulshan. Gulshan ka to I'm not sure if he's gone through it. He's just attending a session today. Muskan, Nukul, Prerit, Chaitanya, Vishnupriya. Where's Suchita? Not sure where's Suchita. Yeah, Suchita is here. What do you mean by rotor up and away from the pilot? Chaitanya, answer.
Sir, actually, this means that the aircraft, the rate of turn indicator, it has an aircraft inbuilt in it, which is going away from us. And so it has a rate gyro, the rate of turn indicator.
Rate gyro तो चलो ठीक है, सबको पता है. वो point moves up and away from the rotor. Chaitanya trying to guess in the right direction, but no. मैंने सिखाया क्लास में साफ साफ सबको सिखाया है. मतलब आप लेक्चर में ध्यान नहीं दे रहे हो ना. लेक्चर में यू आपको नहीं बोल रहा हूँ चैतन्य, एवरीवन. लेक्चर में मतलब स्टूडेंट्स यू आर थिंकिंग दैट जो मेरे को सही लग रहा है मैं वही सुनूंगा और जो नहीं लग रहा है वो नहीं सुनूंगा, राइट? है ना, मतलब तो यही है. But at least Chaitanya responded. I'm happy to see that positive change. But वो इतना लेट बोला चैतन्य, 2 सेकंड और रुक जाते तो डांट पड़ जाती कि एक्नॉलेज तो नहीं कर रहे हो आप. बट गुड.
iPad hang हो रहा था actually.
No issue, no issue. You're doing good. I'm complimenting you. Something is better than nothing, right? I'm driving. I'm flying. This is my rotor. Now the rotor can move in 2 directions. It can either move this direction, clockwise or anti-clockwise when viewed. Okay. So let's say my pilot is like this, sitting here, like this. This is my aircraft, like this. So inside this, my gyro, it moves up, the rotor of the gyro, up and away from the pilot. It's not moving in the direction of pilot. This would be moving in the direction of pilot. This is moving away from the pilot and up because it goes up like this. This is the motion of the rotor. Up and away, up and away, up and away. Nothing else. It's just moving in the forward direction. That's it. It was so clearly explained in the class. मिस मत करो यार स्टूडेंट्स, क्लास में वाली चीजें तो मिस मत करो आप लोग. सो होता है कभी कभी, कोई प्रॉब्लम नहीं है, बट भूल कैसे गए आप लोग? भूलने का काम थोड़ी है हमारा. अभी एफर्ट नहीं लेंगे तो भूल ही जाएंगे ना. Sandeep, did you get the answer to this question?
I get it, sir. I'm just trying to, see the images of rate of turn indicator rotor.
जो बताया वो दिखा क्या?
Yes, sir. I understood.
Did you understand the answer? Yes or no?
Yes,
What was
sir.
the confusion?
I mean, I was assuming the rotor to be in a stationary place and rotating in a fixed place, and I am not expecting it to move up. I understood the upward thing.
It is in the fixed position only.
Okay.
This is the motion. You're thinking
Okay.
about it going like this. No,
Yeah,
I was
okay.
just, no, yaar. It is moving in its own place in this forward rotation. Only two rotations, one behind and one forward. Up because from this angle it is going up. Forward because the moment it comes, it goes forward. Forward
Okay.
as in it doesn't change its position. It's the rotor rotation.
Okay. So it's like it can be called as anti-clockwise also.
No, it is
Okay.
with respect to the pilot, they are saying.
Okay.
This is with respect to the pilot, like this. The pilot is not sitting there.
Yes.
Students,
Understood.
get it clear. If you're not getting it clear, it means you're not working hard. अभी कुछ और ही चीज समझ लिया. रोटर क्या वो टॉय है, कैसे निकल के बाहर जाएगा? रिजिडिटी कहाँ से मिलेगी फिर मुझे? Students, take a fixed point on the rotor. Take a fixed point on the rotor and see where the fixed point goes. If this finger is the fixed point of the rotor, and if this is how the pilot is sitting, let's say this is how the pilot is sitting, then if I take this point, which is behind me, which you cannot see because it is towards me, first this point goes up, and then it goes forward, then it goes down, then it returns to me, then it goes up. 4 quadrants, movement from 0 to 0980, 180, 270, 360. But I'm not sure if you're going to understand that. The rotor moves away from the pilot, up and away from the pilot. Thus, it down and towards the pilot would mean it is rotating in our side. Up and away means it's rotating away from us. If it would not have been stationary, it would have come to you like this. But it is stationary, so it cannot go out. But it is moving in the forward direction. The rotor motion is forward. That is up and away from the pilot. Exams, they will give you new options which you would have never studied in life. What will you do there, students? Think about it. What will you do there? Especially when this is taught in the class. If I have to ask you all, Chaitanya, why did you not remember this when discussed in class? You gave me an example saying, sir, meko away ka ek cheez yaad hai, that the aircraft miniature is looked at from the tail. Away bhi nahi hai, but somewhere you clicked. But why was the rotor not being clicked in the mind? We didn't revise, or we didn't solve the paper, or after solving the paper, we didn't resolve the paper. Something or the other, right? It is there in the text. It is there in the text. Text is hardly any 3 or 4 pages. I've taught you everything from the text. I've given you the text. I'm giving you the questions from the text. Still, when we are not having 100% thing, then how do you assume yourself to get proper marks in the exam? Think about it. If you still don't understand, students, tell me nicely. But my question is again, students, if you don't know the answer now, then why are you not discussing it with me after the test? Why do I not have your doubts in question for the test? Why do I only have Muskan and Sandeep sharing it with me? Why do I not have others sharing with me? And if you are not sharing with me, then why don't you have an answer right now? So somebody is somewhere not doing what they are asked to do. It's a wake-up call for everyone, okay? संदीप समझ आ रहा है? मुझे समझाओ रोटर
Clear,
कैसे समझ आया तुम्हें? Please explain what do you understand by this?
Yeah. So basically, the turn indicator has a rotor inside it. So it is opposite to the pilot, and it moves in a up and away, which actually is in a it can be when seen from the pilot perspective. It will move up and away, which will do a circle away from the pilot.
Mm-hmm.
Rotor
Mm-hmm.
movement will be up and away.
Students, every gyro will have a rotor. Are you aware about this, Sandeep?
Yes, sir.
Every gyro has a rotor axis. Gyro axis, are you aware about it?
Correct.
This is, if this line is a gyro axis, and if I make a rotor like this, okay, so now this rotor can move in two directions, either this direction or this direction. Can it move in any other direction, students? Can it rotate in any other directions about its axis? Yes or no?
No.
Sandeep is
Negative.
saying no. What about others? No, it will only move either
No, sir.
that way or this way. Okay. If this is where my pilot is in the aircraft, then my rotor moves up and away. It moves in this direction, nothing else. And this is the nose of the aircraft. And this is your cockpit. Inside, the side windows, however you want to see it. I'm not in the mindset to make such diagrams for you right now. But do you understand, if this is your pilot here, pilot is seeing here, this is the nose of the aircraft. So the gyro is aligned like this. Horizontal axis gyro. While the rotor is aligned with the longitudinal axis. Have you all forgotten that, students? And it is aligned with the longitudinal axis like this in line. And the rotor is just moving up and away from the pilot. Up and away in its own position. It doesn't go out. It doesn't go out like a free wheel. And then little bit of precession while turning, along with the spring adding secondary precession, gives me accurate rate of turns. That's the whole functioning of the TSI. And the vertical axis about which it measures the turn is this. The vertical axis. All turns are about the vertical axis only. Although we bank and measure a turn, but turn is, remember, the angular measurement. How many degrees per minute? Degrees are measured in the horizontal space. See, students, when you do proper revisions and discussions, in the end, you learn what loopholes you have right now. I don't know why you're rushing to go ahead when your other things are only not thorough, right? So be very careful. Yes, Sandeep, please go ahead.
Yeah, sir. I was actually, referring previously, it could be called as anti-clockwise also, but now I understood, because from when seen from the left side, it is anti, and when seen from the right side, it is clockwise. So
Now
that is the
that's
reason why the
intelligence. Now,
yeah.
yes. So it cannot be said clockwise or anti-clockwise. See, well said. Now you know the reason why. Very good. I like that. What is the measure of rate of turn in this? The angle of tilt. The angle of tilt of your rotor is the measure of rate of turn. Do you agree with it? Yes or no? How many say yes? Raise your hand. The angle of tilt is a measure of rate of turn. So Nukul, Vishnupriya, Suchita, Prerit, and Gulshan. So you're saying no. Nukul and Prerit. So you're saying no. Everybody else is saying yes. Nukul, tilt. Tilt last में ही होगा स्प्रिंग विंग के काम होने के बाद. टिल्ट के बेसिस पे ही मुझे रेट ऑफ टर्न मिलता है.
Right, sir. Banking.
Exactly. Yes,
Yes.
the angle of tilt is thus a measure of rate of turn. Such one lines from anywhere are picked up and given you as questions, students. ठीक है, good job, everyone. I'm just expecting us to do all these things very quickly. It should not take long time. Stop limits to the movement of the gimbal to tilt corresponding to a turn of about dash per second are provided in TSI. Stop limits for the movement of the gimbal to tilt corresponding to a turn of about dash degrees per second are provided in a TSI. 10 degree per second, 20 degree per second, 30 degree per second, or 40 degree per second. Now, this is a unique sentence that you have had. It's 20 degrees per second. If we have a tilt corresponding to a turn of about 20 degrees per second, then there will be stops to limit the movement of gimbal. The gimbal will not move beyond that when we have a tilt resembling a turn of 20 degree per second. So whenever you have tilt of the rotor, that's when you have a turn indication, and the tilt will happen when the aircraft is turning. So there are stops provided to ensure that the rotor doesn't tilt more than required. And what is the value? Value is 20 degree per second. It could vary with respect to various situations. Keywords. Good, good, good. Students, any more doubts with TSI? Feel free to ask. The more you clear, the better it is. Students, any more doubts here, there, anywhere with respect to TSI? With respect to test, any more errors, any more debates, whatever. These are Oxford questions. They are important. Okay. Very important questions. Universal questions, I would say. Printing errors are not your problem, not your mistake. But when you are practicing, you should be aware. That's why I'm a little alarmed right now that ये क्या हो रहा है? And it's been how many days before is the issue. Can you tell me if TSI gyro can topple or not? Nukul, Gulshan, Chaitanya, asking you all the question. Can a TSI gyro topple or not?
No, sir.
Because we have stops, because it has only one gimbal, it will not topple when it comes against the stops. That is the only explanation given. As there is only one gimbal, the gyro will not topple when it comes against the stops. It will not topple. All key points are mentioned. Try to remember them. Okay, nothing, right? We will do a very simple topic for you to study. Now, in this topic, couple of things you will not understand easily. Give it some time for you to study those things. What are those things? They are things with respect to what is happening to a particular radio wave, as to how exactly is the technical radio wave traveling or the measurement is being made. But apart from that, I'll explain you everything in a very simple way, and you are required to note, understand, then give a quick read after the lecture and be ready for basic tests. They could be asked anytime, is the idea. What is this topic that we are talking about? This is a type of altimeter. What is altimeter? Altimeter is a, who can tell me what is altimeter? Is it a differential pressure gauge? Is it a pressure sensing device?
Pressure sensing device.
It's a pressure sensing device. So which instrument is a differential pressure gauge?
Yes,
ASI.
ASI, and one more someone was saying ASI. I have asked you all to revise piezostatic systems. How many of you all have done it, not done it? Let me know. Sandeep, I want you to text me your status. If you have not gone through piezostatic lectures, then I can give you lectures for you to study before you revise. At least you can do basic piezostatic. Information I need on chat so that it stays there in case I forget. So I'm thinking that there are certain topics which you might not have studied well or want to. I could give you lectures every day. You can attend couple of lectures topics offline, that is, and then live also, and then practice also. So that is the idea, for you to cover up everything in a very homogeneous way. So I would want to know if you are interested in doing that. Otherwise, I don't know how you're going to study things on your own when you're revising. It's going to be senseless. You should attend a lecture on some topics and then revise and then attend. I think that is a wholesome idea. So that is what I want you to do. I just need to know what topics you would want to study and what not. So first we can priority-wise do on that. But I'll explain that to you again once, but that's the idea I wanted to discuss again, like, yeah. Very good. Gulshan, तुम्हारा कुछ अलग ही चल रहा है, मेरे को पता है. You are on a full mode of preparation. You are doing some things on your own, but I'm not sure if you are staying true to the plan. But I would need an update regularly for you also to give me. So what is this altimeter? Is a pressure sensing device. But what's the purpose of altimeter? The purpose of altimeter is to indicate altitude of an aircraft by sensing the static pressure. We compare the pressure sensed with respect to certain datums. So we know altimeter, we know much about altimeter. This altimeter that we are going to learn is an altimeter based on radio waves. We call it radio altimeter. In short, it is also called as radalt, how you want to call it, radio altimeter. Now, it's an electronic device. When I say electronic, it means it uses radio, transmitters, receivers, antennas, frequencies. Okay. How? How do we do it? Very simple. If I have an aircraft, then in the aircraft, I will have an antenna for my radio altimeter, a transmitter and a receiver, both. These antennas are flush mounted. When I say flush mounted, they are flush to match with the skin of the aircraft. They don't protrude out much. VHF antennas are fin type antennas. Generally, they can protrude out much. HF antennas are also like that. But these antennas are flush mounted. They are like very nicely meshed with the body of the aircraft. Horn antennas. Horn antennas, the antennas look like this. Horn antennas will radiate radio waves in an increased radiation pattern. Okay. So a radio altimeter will have two different antennas, one to send a signal and another to receive a signal. My radio altimeter will use radio waves or frequencies between the super high frequency band and ultra high frequency band. Okay. But presently the use is made only in the super high frequency band. What is super high frequency band? How much is it? We will be notifying that. So I'll say the frequency for radio altimeter used is in the band of SHF and UHF. Can anyone tell me the range for UHF and SHF? Sandeep, are you well versed with basic radio wave theory, frequency bands, tables?
Yes, sir, I do.
Good. Who can give me the answer to this? Please, students, go ahead. What is the frequency band for UHF and SHF? Yes.
Sir, UHF is 300 megahertz to 3 gigahertz, and SHF is 3 gigahertz to 30 gigahertz.
Okay. So radio altimeter, thank you, Prerit. Radio altimeter uses frequencies in the UHF and SHF band. In SHF, the frequencies used are 4200 megahertz to 4400 megahertz. This is what we use currently. And in UHF, we have a lower frequency used, 1600 megahertz to 1660 megahertz. But in circulation is this 4200 megahertz to 4400 megahertz in the SHF band. You will get a lot of MCQs for radio altimeter. Okay. Like in practice, you'll get some. So you be careful about these points. So what kind of frequency modulation am I using, or what kind of amplitude modulation am I using, or what kind of modulation am I using in this particular system? Simple question, right? We use a frequency modulated continuous wave. So there is no audio signal going in. So you don't really need superimposition type of modulation for data, but then you need some sort of modulation for your radio frequencies. So the signals sent are F for frequency, M for modulated, frequency modulated, C for continuous, W for wave, continuous wave. Why frequency modulated continuous wave? It is how it functions. Secondly, radar. If you think about radars, they have pulse. They don't have continuous waves. So somebody can confuse you saying, oh, radio altimeter is just like radar, so it has pulsed waves, right? And you might end up saying, yeah, pulse hi hoga usme. Pulse is like small bursts, not a continuous wave. So a frequency modulated continuous wave will be like this. And one which is not continuous will look like this. In simple words, this is not continuous. This is continuous. So radar principles generally use pulse techniques, means the wave is not. But radio altimeter uses a frequency modulated continuous wave. So it radiates a frequency modulated continuous wave in a elliptical pattern. Keywords, okay? Especially for the examination. Elliptical pattern follows a pattern of an ellipse. Okay, just note this. Right now, I would suggest try not imagining it right now. We are going to leave a small part with respect to functioning while we are going to study all other important parts with respect to visuals and indications and theory behind it. So the radiation pattern is elliptical and it goes vertically downwards. Now, what happens if this is my ground? My radio wave will be shot down and then it will be received up through the receiver. Okay, through a flush mounted horn type antenna, a frequency modulated continuous wave is radiated vertically below the aircraft, and a signal is received by the receiving aspect of the antenna. And the time difference between the sent signal and received signal is measured. And the time difference is converted into the distance that is measured. So what is the function? What is this distance? What is the function of radio altimeter? Function of radio altimeter is to measure this. What is this? This is height of aircraft above ground. Height and not altitude. Altimeter can be said to be measuring altitude above mean sea level or above any other reference that we have. But radio altimeter only measures height above ground. Why do we need it? We need it for accurate readings of height. Especially the accuracy given by radio altimeter is super high. Okay. It is very accurate. Accuracy could be up to 1 feet plus minus. Secondly, whenever you're doing low level flights, especially during approaches, your radio altimeters give you good indications for your decision height and to show you whether you are at the decision height, low, above, and give you warnings also for low altitudes. They're very accurate. But they are limited to only 0 feet to 2,500 feet. We don't use radio altimeter to get an indication more than 2,500 feet. If your indication measured by a radio altimeter becomes more than 2,500 feet, the indicator is masked behind a mask of the instrument. You cannot see it. So that's one limitation, and which is not an issue at all because we only use it at lower altitudes. So the first function of radio altimeter is that it is a device capable of measuring the height of an aircraft above the ground with a high degree of accuracy. But there are two more important functions. What are those important functions? First important function is that when you are using automatic landings as a part of your autopilot systems, then associated information with respect to minimum altitudes, decision heights, and all are given to that autopilot system through the radio altimeter only. Second most important application, apart from the accurate height and apart from the provision to autopilot for landings in conjunction with ILS and MLS, the third most important use is that it gets its data, or it gives its data to ground proximity warning systems, GPWS. So uses of my radio altimeter is to determine aircraft height above ground level with high accuracy. Okay. Number two will be give info to autopilot systems for landings. Third would be provide info to GPWS, ground proximity warning system. What kind of information? Height and rate of change of height. Again and again, it is mentioned that radio altimeter is a very intimate part of your GPWS, we could say, a very important part of your GPWS. Now, there is one key point that you need to know about the functioning of these radio waves. Okay. The radio waves that are going down and going up, they are not kept the same. There is a difference of plus minus 50 megahertz in the signal sent and the signal received. Through certain computations, it is achieved. And this difference actually helps you get a proper reading of the time difference between the sent signal and received signal, and the time difference and this change in the received frequency of plus minus 50 megahertz helps me complete one cycle that gives me a height indication. Okay, this is a key term, a very important term. Sent frequency, received frequency, difference in the frequency plus minus 50 megahertz. Chaitanya, what's on your mind?
Radio altimeter gives height from 0 to 2000 feet only. Just confirming.
क्या लिखा है यहाँ पे?
I was just confirming.
नहीं, तुमने क्या बोला मैंने सुना नहीं.
Sir, radio altimeter only gives height from 0 till 2500 feet.
Yes, that's what I said. Yes. It will not give you height more than 2500 feet. Even if it measures on the indication, on the indicator, the indication will be masked. It will not be visible. The scale of your radio altimeter is only designed up to 2500 feet only. Yes, Muskan, what's on your mind?
Sir, can you please repeat this plus minus 50 megahertz part again?
The received signal is differentiated by the sent signal by adding or subtracting 50 megahertz to the frequency. It's a complicated mechanism, but you need to know this, that the transmitted frequency, it changes by a fixed rate by a rate of plus minus 50 megahertz, so that the received frequency has a difference of 50 megahertz compared to the transmitted frequency. The frequency is purposely changed by 50 megahertz. That is the key element that helps us get the actual height indications when the time is measured with respect to sent signal and received signal. The sent signal and the received signal are different because the sent signal is constantly being varied by a value of 50 megahertz. So the received signal doesn't remain the same. The received signal also changes. Because of this and a little bit of more theory involved, which I'm asking you all to ignore right now, together we get a measurement of time taken for the radio wave to travel to the surface and from the surface. And that time measurement is a derivative of my height above the ground. So the frequencies are changing during transmission. So I'll repeat the statement again. The transmitted frequency changes at a known rate from its starting point to plus 50 megahertz and back again to complete a cycle. Now, this statement here is one point where you will get 50 megahertz in the text. Again, as you go ahead, you will see plus minus 50 megahertz. This 50 megahertz is a key term in aviation and a very common term in aviation when it comes to radio altimeter. Different books will tell you in a different way, but the logic is simple, that the frequency, okay, is changing by plus minus 50 degrees, plus minus 50 megahertz, the frequency is not constant. That's all that you have to remember. 50 megahertz is the case. Now, if you're thinking, sir, what frequency? Then this frequency, 4200 megahertz. So, for example, if I'm shooting out 4200 megahertz, then at some point in time, my frequency will change to 4250 megahertz before it is sent up. And once it comes back up again, it will go back to 4200 megahertz. This technique of varying the frequency by a known rate, which could be 50 megahertz, is important to be able to derive a height based upon the transmission and reception and the time taken between the two to give me the height. Are you understanding this, students? With an example, if the transmitted frequency was 4300 megahertz, then at one point it will be changed to 4350 megahertz and then back to the same frequency again. This is important. This needs to be done because of this. Something happens that allows you to give accurate readings of height with respect to the time gap between the sent and the received signals. Are you understanding, students? This much at least, step by step, go there. Muskan, are you getting it? Or not getting it? See, I will read out a point about the functioning of the radio altimeter. The radio altimeter determines the time taken for a radio wave to travel from the aircraft to the ground directly beneath the aircraft and back again. What does it do? The radio altimeter determines the time taken by the radio wave to travel from the aircraft to the ground vertically below it. So they are saying that they are measuring the ground directly vertically below me, here, straight down. And to the aircraft and back again. During this time, the frequency changes at a known rate by 50 megahertz and comes back to its original frequency to complete one cycle. What is this cycle? This is one cycle, basically. Now, this is not how your instrument will measure because your aircraft will be in forward motion. And there are a lot of other things involved, mainly Doppler shift, Doppler navigation, and a Doppler effect is also a cause for an error in this. But that is not important for us doing CPL right now. It will only confuse you right now. So if you can understand this much, it will be great with respect to key terms in the first level. Second level, once you are done with the basics, you could go into a little depth and try to understand what's happening. But I like your questions, students. The more questions you ask, the more you will learn. Students, every frequency, every type of modulation has a radio frequency and a carrier frequency, right? So remember that also, okay? I want you all to write a note with respect to the functioning of radio altimeter right now. The radio altimeter equipment compares the frequencies of the transmitted and the received signals. And since the rate of frequency change is known, so see, it's comparing the frequencies, the one transmitted and then received, and they know it at a known rate. We are not told what the rate is. Understand, okay? Very little information is given here. It becomes very difficult for the student to understand. But when a little information is given, we understand that that is not of much priority, but still we need to understand to make logic. So what is this frequency difference? The frequency difference is gathered because we know the rate of frequency change, 50 megahertz. If the measurement is quantified with respect to this, then the frequency difference between the sent frequency and received frequency, it itself becomes a measure of the time taken for the radio wave to travel to and from the surface. Here, the key element, one basic principle for radio altimeter is that the difference in frequency between the transmitted frequency and the received frequency is an indicator of the time taken by the radio wave to travel to the surface and from the surface. Now, this in totality is the actual principle of radio altimeter, which is why I am compelled to discuss this point, because at least the principle can be asked in the exams. So it measures the time between the sent signal and received signal. But how? So you'll say when the signal is sent out vertically down to the ground, the frequency changes by a fixed rate of 50 megahertz. If the frequency difference can be measured or can be analyzed, that frequency difference between the sent frequency and the received frequency will be indicating the time taken between the sent signal to the surface and the received signal back from the surface. And that time will give me accurate height indications. So this 50 megahertz is very important for us to understand. Again, I'll say the same thing. What is happening when the radio wave is being radiated vertically down? As it is being radiated vertically down, it will be changing at a constant rate, and the rate can be said to be 50 megahertz added. So if this signal is 4200 megahertz, the other signal will be 4250 megahertz. And if the received signal and this signal are just 4200 megahertz and 4250 megahertz, then 50 megahertz will be one instance, and properly that one instance would be relevant to maybe 1 second. We have not been given the time right now, so we don't know what the rate is. So if that was 1 second, so the time measurement would be just 1 second, and 1 second based on the speed of light or the radio wave in that case, which is the same, you can determine speed, distance, time on computations inside the radio altimeter, and quickly it will give you answer in feet. Are you getting me, students, now how it is working? It is working by measuring the difference between transmitted and received. So if my transmitted signal and received signal have a difference of 150 megahertz, then I know 3 times the frequency change. And if the rate of change was per second, then probably the time difference would be 3 seconds in that case. Now, this is a hypothetical example, but this is as close as we can be to the actual learning without using any technical jargons. But now, even if you don't read, you know the reality. The reality is that the difference between the two frequencies, sent and received, how much will be the difference? The difference will be as per the measured rate of change of my transmitted frequency, which will be in the lines of plus minus 50 megahertz. So if I know the rate, and if I measure the signals, and if I realize the signal is such that the rate is 5x or 10x, so very quickly I get the time, and as per the time I get the height indication. Are you following, students? Such questions will be asked to you based upon these points. We know what is the frequency used, SHF and UHF, 4200 megahertz to 4400 megahertz, 1600 megahertz to 1660 megahertz. There is one keyword, total sweep. Now, this sweep could be measured as the entire effect of the transmitted and received signal. I'm just mentioning this keyword here. The total sweep of the carrier frequency they're just saying that there is a carrier wave which is frequency modulated, and that carrier wave will be the important wave, high frequency SHF band. So the total sweep of the carrier frequency is varied automatically plus minus 50 megahertz 300 times per second. So now you're getting a value close to the rate which it could be. So if you see the difference to be 50 into 300 or something, then 1 second delay, and that 1 second delay of reception and sending would ultimately give me the height indication. Now, these are the reasons why I'm not getting provisions about 2,500 feet also. But then I don't use it about 2,500 feet. I want it for lower altitudes only because ASI or altimeter is not that accurate for me. The beam can be conical or elliptical. See, this is circular beam. From my side, if I have to see, then the beam would look like this in a circle like this. Elliptical beam would be a little longer like this. And this looks like cone. This becomes ellipse or this becomes circle. So here it is elliptical. It is like how much you have on a flashlight. When you radiate a flashlight in a sea of dust, you see the ray of beam. Similarly, they're talking about the radiation pattern. Now the antennas are designed in such a way, the flush mounted antennas and the elliptical or the conical beams are designed in such a way that your altimeter can give you good indications even with pitch angles, of plus minus 30 degrees and roll angles of plus minus 60 degrees. Also write one more point, height of the aircraft. It will be determined from the shortest path between the antenna or between the aircraft and the ground, which is directly vertical below the aircraft. These little terms are there everywhere in your MCQs. The options are such that you need to be very careful. Very careful. Okay, yeah, I understand and this is the correct statement. I understand and this is the correct statement. Now, because the transmission is continuous, we have to use separate antennas for transmitter and receiver. Your radar uses similar techniques, but radar uses a single antenna. Because of pulse techniques, it is allowed to do so. But here, because we have continuous wave, we cannot use the same antenna. We need different antenna. So if anybody ever tells you, why is a radio altimeter using not one but two antennas, you'll say the transmission is continuous. That's why we need separate antennas for transmission and reception. And the receiver antenna, the reception antenna should be placed as far as possible from the transmission antenna to avoid interference with each other. Or the receiver signal should be kept far and wide away from the first one to avoid interference with the transmitted signal. Gulshan, do you have something on your mind? Yes, no, maybe?
Negative, sir.
Fine. Remember these key points, students. Okay, when you will be going through the text once to read, the points that we are not covering are just couple of paragraphs with respect to the which anyway we have covered in ignoring the complicated points there. You will be reading everything, of course, so be on the lookout and mark these points that I'm discussing right now and you're reading in the text also, so that revision is double before you give the test or before you give the exam. Radio altimeter, the signals that are radiated, their power generation, or we can say radiated power generation, is of the order of 1 watt. So if somebody ever has to ask you about the power rating of the signals or the power rating with respect to the radiation on a radio altimeter, then you can say that it's of the order of 1 watt. I have another question. Is radio altimeter installed in training aircraft? It should be. It should be. Why not? Of course, it's not a primary instrument. Altimeter is a primary instrument. So chances are it might not be. Depends. Be on the lookout. You can easily spot it by looking for an antenna. Of course, in this aircraft, no antennas are there. It's like a small case. It's like a rectangle case, flush mounted. This and this, two places. You can easily spot when you do an extended transit of the aircraft, a walk around of the aircraft. One of the essential checks in the walk around of the aircraft will be to visually inspect the condition of all your antennas. That's when you will actually learn to spot all the antennas of the aircraft. Probably B737 or A320, whatever will be flying, or any other aircraft. Training flights can or cannot have. I think they should have, of course, especially for IFR training and all, you should have radio altimeter. Students, I understand that things are not easy. Over and above that, if you're not able to remember things, it becomes much more problematic. So my job is to make difficult things easier for you to understand. And again, I'm giving you techniques to make your memory strong. Hard work will be from your side to increase the memory retention. Understanding, you leave it to me. Connecting the dots based upon basic understanding is something I'm expecting you all to learn to do, and I'm pushing you to do it. If you think sir is just pushing and you think sir ko na bhi nahi bolna hai because sir bhadak rahe hain, and if you're not doing it and doing something else, then I hope that something else is foolproof. Okay, remember that. Let's take a short break and we'll continue about radio altimeter. We'll look at the indicators and we'll look at the different do's, don'ts, limitations, what kind of scales are there, what kind of flags are there. Okay, so let's quickly come back at 6:30, everyone. Just 14 minutes. Please don't be late, all right? 1830, please come back. Hardly 13 minutes left. Consider it a short breather. Okay, students, welcome back. I think couple of students are yet to join. Let's hope. I think Sandeep is here. Chaitanya, Nukul, Prerit, Muskan, Gulshan, Suchita. So I think Vishnupriya and that's it, right? Just Vishnupriya. Chaitanya, are you here? Muskan? Prerit, Suchita are here, right? Sandeep, you are here, right? Gulshan? Can let me know through reactions. So I think Gulshan is not here and Sandeep are not here. Anukul?
Sir, I'm here. How do I react?
संदीप पहले दिन पे बहुत अच्छे से समझाया था, आप वो भी भूल गए हो. देयर आर रिएक्शंस ऑन द जूम ऐप पे रिएक्शंस करके है, देखो ना, थोड़ा दिख जाएगा आपको. सी आई एम रेजिंग अ क्लैप राइट नाउ. So whenever you have to say yes, you use that like this.
I mean, I put this before, sir. Like, I've already done that, so I thought.
And when you say no, you say no. No, it's okay. I mean, I was just cross-checking. I always cross-check 2-3 times most of the times. बुरा मत माना करो यार students. Come on. Good, you did it, right? Great, you already know it. Well, that's what I'm wondering. It's such a simple thing. Good, good. Okay, where is Vishnupriya? All right. Students, let's talk about the instrument itself, the indicator, a very simple indicator, but can be confusing if you don't know about it. Okay. I have a picture. You'll see the picture again. And I'll share the screen with you now. Okay. I hope you can see the cursor also on it. Yeah, you can see the cursor, right? Okay, zoom in a little bit. Now, first things first, let's talk about the scale. Okay, everybody write down about the scale first point. The radio altimeter scale is a logarithmic scale. And it is not just logarithmic in nature, students. Okay. Not just logarithmic, but it is also non-linear. Students, if you have not gone through the basic instrument lecture where we talk about accuracy, indication, indicators, what kind of indicators are there, which is basically the first chapter in instruments, then I suggest we do that. So there we learn about the different types of scales. Now, why is it called logarithmic? Now, the point from here, 0 feet, till here up to 500 feet, it is a logarithmic scale that is expanded for more accuracy. So every element from 0 to 1 will give me 100 feet, 200 feet, 300, 400, and 500. This much part is a logarithmic expanded scale to denote 0 to 500 feet. Thereafter, the scale is reduced to a non-linear scale. It is just not linear. Of course, we know logarithmic scales can be considered as non-linear scales, but then a reduced non-linear scale indicating from 500 feet to 2500 feet. And this point here is where 2500 feet ends. So this little gap between 20 and this little index marking here is 500 feet itself, while the whole semicircle of the instrument itself is also 500 feet. So the indication is not linear. It is logarithmic expanded up to 0 to 500 feet. Thereafter, from 500 to 2500 is non-linear, and it is reduced in its indications. That is about the altimeter scale, radio altimeter scale. Are you clear with this? Simple. radio altimeter scale is expanded logarithmic scale from 0 to 500 and then reduced nonlinear scale from 500 to 2500 feet. Simple, right? Okay, good. I'm not getting much of acknowledgement, but I'm assuming you're not saying no, so that's right. Second important point is the mask. No, students, now if it's now in this second half of the session after the break, if you don't say yes, it's fine with me. You say no if it's not fine with you, only then. If you don't say anything, I'll assume you're saying yes. That way we can do quick acknowledgement. What about mask? This is the mask. This yellow color that you see is actually a mask. You can think of it as a sheet of paper or a different material if it's a real instrument. So you cannot see anything behind. Why is this mask needed? Why is this mask needed? A very important point, a mask in a radio altimeter. With respect to this example, you see the pointer is behind the mask, they are saying. So although we can see it, the yellow shade is marking what the mask would look like, and the mask would not be transparent. All right, it would just hide the indicator for you. And here the denominations are also into hundreds of feet. That is fine. Now, what is the purpose of the mask? The mask is very important. For a pilot, it is important to know what the mask does. Firstly, whenever the altitude exceeds 2500 feet, the mask would come into place. So we cannot see more than 2500 feet. Second thing, whenever there is an error in the transmitted signal, the mask would come. So if the system in itself detects that there is an error in the transmitted signal, the mask would appear and the pointer will disappear behind the mask. Which pointer? It is the height pointer. It's only one pointer based instrument, and this pointer will show me my height. This pointer will be behind the mask, or it will disappear behind the mask in three situations. One, whenever the altitude exceeds 2500 feet. So Chaitanya, you were asking the doubt. It is cementing in itself again that above that, you will not get an indication because the pointer will be masked. So even if the altimeter is sensing a time difference that is giving me an indication more than 2500 feet, the pointer will be masked. In this case, I'm getting it close to the entire movement of the instrument. So it is masked. It is clearly beyond 2500 feet. Maybe behind the mask, little more graduations of 2500 are there. Maybe not. But the pointer will be masked, remember, based upon instrument to instrument. This is an analog instrument. Indicator is analog, although it's an electronically digital instrument. Second, whenever there is a fault in the transmitted signal, the pointer will be disappeared behind the mask. It means the system will not let you depend upon the reading of radio altimeter. And the third is whenever the altimeter is switched off. Three reasons why the pointer will be behind the mask. When the altimeter is switched off, radio altimeter, when the altitude exceeds 2500 feet, and when there is a fault in the transmitted signal. Got it, everyone? Sure. The next important element first is the scale. This is the pointer in the center. This is the entire mask. Then what you have is failure warning flag or flag alarm. This one here in the center. This is a failure warning flag. Okay. When does this come into action? When do you see this activated? The flag appears whenever you have too much of radio noise or you have reflection of your transmitted signal from the aircraft body itself. We call it local reflections, or when there is loss of power to the equipment. You will get warning flags. We're not talking about masking. We're talking about warning. This in the center is the failure warning flag. The flag will appear whenever there is too much radio noise, which will disturb or which will contaminate the returning signal. Radio noise, too much of static, too much of interference for the received signal. Radio noise affecting or corrupting the received signal. I hope you're making point of these points. I'm not writing because I'm showing the screen. I cannot show you the other screen. Radio noise corrupting received signal. Second is local reflections from the airframe itself, or in the event of loss of power to the equipment, you will get warning flags. Mask, 3 different reasons. Warning flags, 3 different reasons. Okay? That in the center is your flag alarm or warning flag. Next point that you have is this point on the right, this segment of the instrument. Press to test or height selector. When you press it, you can test it, or when you move it, you can select a height that you want to choose or mark as a low altitude index. And this here, this moves, this little index here. If you rotate the knob, it will move and you can preset a selected safe height. It could be decision height or it could be a buffer height that you are selecting for your approaches. So this press to test is not just one, but it's a two-way thing. Press to test, you test. Whenever you test, whatever height you have selected, the pointer will come to that height. That's how it works, the testing feature. A preset altitude, you can set a low altitude index also. But the test is for a preset altitude. Now the test phase is simple. For your determined instrument, there would be a preset altitude on which the instrument should come whenever you are pressing the press to test button. It will be given to you in your manuals or in your training. But there is also a feature that you get along with the press to test button. That is height selection button, the same button that you press. If you don't press, but you move it right, move it left. When you move it, when you turn it, you can select a reference low altitude index for your desired height so that you can have a reference to maintain your lowest altitudes. So whenever you press the test button, the height pointer swings around to a known preset altitude. This check provides confidence to the pilot that the operation of the instrument is very satisfying if the test is working fine. So it's one of the pre-flight checks. You could do it during then. The second would be that the button is dual purpose. When turned, it will select the reference low altitude index to the desired height. So you can set it to 300 feet, 200 feet, 500 feet, 100 feet based upon your requirements for your reference. So when you'll be flying using radio altimeter, you'll be learning these things in short that, okay, we'll set a reference height, we'll measure with the reference height, so and so. So that's the press to test and height selection button or height selector. Two purposes. When you test, the pointer swings to a preset altitude with respect to your manufacturer or accepted instrument that will be preset for your test purposes. When you press it and it comes on the preset altitude, it's working fine. If it's not coming on the preset altitude, it's not working fine. That's the importance. And when you rotate the knob, you can set the low altitude index to your desired height for your reference. The last but most important indication that you could easily get is the low altitude warning light, which is this light, this one here, low altitude warning light. Now, when do you think the low altitude warning light or low height warning light illuminates? It illuminates when the aircraft is flown below any pre-selected height by the pilot. If a pilot has set a minimum altitude as a minimum safe altitude to be flown with respect to these low-level flights, and if our aircraft is flying below that height, then my indication will be given to me through a low altitude warning light. And along with visual notification, I'll also get a tone which will end after some time, but the tone will be increasing in its loudness and the tone can be sounded approximately about 100 feet if you have set your decision height in your instruments. Now, this decision height can be set in your electronic instruments or electronic flight instrument systems for your aircrafts. Decision heights are those heights where the pilots would make final decision whether to land the aircraft or to not land the aircraft. It could be 100 feet, 200 feet, 300 feet. So you get a low height warning whenever your aircraft is below a preset height which you would have chosen. What would that choice be? Would that choice be a low altitude index, or would it be something else? That I would want you to keep open for probably understanding better, because no direct indication of that such is given here as to whether the low altitude index in itself will be the preset or pre-selected altitude. But in whatever the case is, your low altitude warning light, if a number is to be given, then whatever your decision height is, approximately 100 feet above the setting of decision height, you will start getting the oral tone, and the low altitude warning light will also be displayed for you to see and for you to be alert that, okay, I'm flying too low and I need to get up. I need to maintain my altitude. The instruments that are digital in nature are designed in such a way that this pointer on one corner, this red pointer shows my setting of decision height. And here the radio altimeter is reading in digits. 950 feet is the answer. As the altitude decreases, the circumference, the line will also vanish and the color will change from white to yellow. And by the time you reach a lower altitude or decision height, the color changes to yellow or amber, we could say, from white. So it is a dynamic display when it is converted into a electronic flight display. And this is the electronic flight display for a Boeing aircraft that you will see. This whole is not radio altimeter, students. This is your AH, TSI, inclinometer, okay? Ground speed is also mentioned. It's your electronic display that has radio altitude and which is here in this top corner. Indicated radio altitude based radio altimeter based altitude is 1,500 feet in this case, and decision height is 100 set here. This one, on the other hand, is for Airbus. In this, you can see the radio altimeter height here in the center. That's it. This instrument here has ASI, normal altimeter reading, pressure setting, waypoints, DME, VOR, speeds. So much more information is there. But if you are above decision height, then the color of radio altimeter indication will be green. And if it is below the decision height, then it will be amber in color. Amber is the basic warning color for these instruments with bigger numbers. So this is where you get radio altimeter on your electronic flight instrument system on Airbus. And the other one on the right hand corner is the one that you get on a Boeing, this one. There is not much to be done apart from these key points. When you do the questions, again, couple of questions are such that are very tricky to understand, but it will be good practice. You have to understand some parts, some points, students, that when you're going through the text, you will come across certain terms that you can easily look up to find the abbreviations. If you don't know how to get the abbreviations, people doing RT and regulations, there's an iCATS doc for abbreviations. From there, you can get it. I can share that with you all. You can do a quick search. Sometimes doing a search on the web is not that easy with aviation terms. Like EADI will be electronic attitude, ADI, PFD, primary flight display, such terms. Decision height, color change from green to amber. Simple. Green when you're above decision height, changes to amber and the digits become bigger in size when you come below decision height. So that the warning is clear that your decision height is gone, you are at a lower altitude, be careful. When we talk about range and accuracy, we know one thing for sure about radio altimeter, that it is highly accurate. Students, in the meantime, I want to tell you all one thing. The reason why I've specified is that I'm keeping technical jargons away and explaining the functioning in simple terms. The reason I say this is because in the long run, you'll remember when you're doing ATPL, you'll remember that, okay, I had to do it now in detail with respect to all the functioning, which by now I'm expected to understand. Of course, not at electronic engineering level, but still at some level. Otherwise, no instructor will say they are missing out something on purpose, right? Remember that, the difference, because everything we are doing is coincident with what is required for PPL, CPL, ATPL. So you need to know the differences somewhere. So don't take it otherwise, okay? Although, because, thanks to Ms. Khan and her doubts, we were able to give you everything without the jargons. That's it. What I've studied, what I've explained, if you just connect it with the 2-3 jargons that you have in the text, read it 2-3 times, you are done for ATPL also then, with respect to what you're required to do. I'm just stating it in the long run. Okay. Test and height selector, low height warning, you know, radio altimeter scale, you know. Make sure you have entered the notes correctly. Expanded, logarithmic from 0 to 500, and then reduced, non-linear from 500 to 2500 feet. 2 for test, 1 to test, 1 to select low level heading, and low height warning is given to us whenever we are flying below a preset minimum altitude. Let's quickly write down about range and accuracy. Range and accuracy of radio altimeter. The radio altimeter can be used between 0 to 2500 feet above the surface, this much we all know, with an overall expected accuracy of plus minus 3% of indicated height or plus minus 1 feet, whichever is greater. When they say greater, it means greater in terms of accuracy. Don't give it in terms of value. Whichever accuracy is greater. For example, okay, if my altitude measured indicated is 100 feet, then my expected accuracy should be plus minus 3%. 3% is 3 feet. So my accuracy should be plus minus 3%. It means I could be at 103 feet or I could be at 9 or 7 feet. When indicated is 100, plus minus 3% accuracy means either I'll be at 103 feet or 97 feet, not more or less, or 1 feet, whichever is greater. In this case, 3% is not greater. 1 feet accuracy is greater because here I'm getting 3 feet. Here I'm getting 1 feet. 1 feet accuracy is greater. So I'll be going with the 1 feet accuracy that is expected. Whichever is greater in terms of accuracy, remember. In case you come across some solutions where they are taking greater as the value as greater, then bring it to my notice. Simple. Generally, if you remember, such questions confuse you here and there. Then you realize, oh, accuracy greater means the lower value. And you see that in classes of AH also I've had some doubts with respect to this value, if you remember, students. Artificial horizon. Factors that affect accuracy. Okay. Students, are you following? Factors affecting accuracy. One is height lag. A description is not given to us to study, but just the names. So it's enough for us to know the names of these errors affecting accuracy. Height lag. Step error in digital counting circuits. And third is Doppler shift. If you are really an enthusiast of radio comms and all, once your exams are done, do a little bit of Doppler shift or Doppler navigation. Understand the theory. It's very interesting and very difficult to understand. Now, one important thing I want you to know that you'll come across in your textbooks is this point. Okay, this is your aircraft. It has a nose landing gear and it has main wheel landing gears like this. Okay. Now what happens? First point, your radio altimeter is always required to indicate 0 height above ground level as soon as the main wheels of the aircraft touch down on the runway. The moment your aircraft touches down on the runway, your radio altimeter is designed to give you 0 feet indication. Okay. Now what happens? The aircraft on ground, okay, will have some compression in the shock absorbers, and these shock absorbers have a term known as oleo. Okay. But when the aircraft is just touching down, they are not as absorbed. They are a little stretched far and wide. And in one of the diagrams, you'll come across that your nose main landing gear is little upright. So what happens? This difference between the wheel and the surface of the aircraft and the wheel and the surface of the aircraft is generally termed as residual height. A very important term with respect to radio altimeter. Residual height. Because the instrument is above the aircraft, but the height measurement is with respect to the landing gears or the wheel touching down. So write down this statement first. The concept here is with respect to problems faced by radio altimeters because of different type of aircrafts and the equipment inside with respect to the cables and connections put in. A Boeing 747 will have hundreds of feet of cable. A small aircraft, a small charter plane will have just a few feet of cable. That length in the cable will also impact the time difference measured and calculated. Okay. And another thing which is very important is this term. Write down this term, everyone. The radio altimeter is required to indicate 0 feet height above ground level as the main wheels touch down on the runway. Okay. Main wheel. So now you see if you have a radio altimeter on a training flight, if you have, then your training flight might not have retractable landing gears. So probably a specific type of instrument with specific residual height would come into picture in the application of that. But when we come to this point, we understand that the radio altimeter has to be extremely accurate and it should be performed, it should be designed to perform at an accuracy of plus minus 1 feet. But because a same radio altimeter can be fitted on different type of aircrafts, okay, a lot of different compensation is to be allowed with respect to me getting a 0 on touchdown. That is very important. Secondly, whenever my aircraft is going to land, the nose wheel landing gears will not be horizontal. They'll be a little tilted. So the residual height increases. While I'm on ground, the residual height will be little less. So the compensation that I need to make to allow for these changes so that I get proper altitude references is very tricky. This term is known as aircraft installation delay. Because of the installation of radio altimeter in different types of aircraft, there will be some sort of delay because of which the height measurements will not be great. So we need to compensate. We need to do something. Write down what is residual height. There is an important definition for residual height. The height difference, please write it the way I'm giving you. The height difference between the antennas on the fuselage and the bottom of the trailing wheels on the main landing gear bogies. Bogies, the whole setup. Okay, the whole setup. So here on this model, we only have one wheel. So there is no leading or trailing. When you have two wheels, first one is leading, the second one is trailing. So if my aircraft is like this, like it's going to land also or take off, like it's not going to land like this, it's going to land like this. So it is the height difference between the antennas on the fuselage. We can consider any point. Now you cannot see, you can consider any point to be the antenna. Antenna to the bottom of the trailing wheels on the main landing gear bogie, the main gear, the whole is called bogie. On the approach to a touchdown. So the whole definition is this: the height difference between the antenna on the fuselage and the bottom of the trailing wheels on the main landing gear bogies on the approach to a touchdown. Very important. On the approach to a touchdown is known as residual height. So from the antenna to the bottom of the trailing wheel of the main gear bogie is my residual height when my aircraft is on approach for touchdown. So this aircraft is going for approach on a touchdown. Looks like it is taking off, but it is not taking off. They also approach like this only. You must have seen, right? You know it. Just that the angle is lesser than the climb angle, or the pitch is lesser than the pitch in takeoff. So that is residual height. So we need to give compensations. The length of the cable in the avionics bay and the position of the antennas on the underside of the aircraft fuselage, the lengths will be varying with respect to different aircrafts. So the difference that you get in a Boeing 747 and a smaller aircraft could be as much as 100 feet to 6 feet for the same indication. So we need to compensate for that. If the compensation is not given in the larger aircraft, then we can go up to 100 feet of error in the altitude indications. So how do we compensate for this residual height and cable lengths? So we say the aircraft installation delay is adjusted to compensate for residual height and cable length. And now that cable length is also twice. One goes to antennas that are transmitting, then from the avionics bay to transmitter antennas, and from the avionics bay to receiver antennas. Students, can you hear me? Yeah, I had some stuck screen. All stations, scale of 5. Good. Almost there, okay? Couple of more points and we are done discussing this topic. So aircraft installation delay is adjusted to compensate for what? For residual height and the cable length are the keywords here. So aircraft installation delay is adjusted to compensate for residual height and cable length. And remember, the cable length is double always because it comes from the avionics bay to the transmitter and goes from the receiver to the avionics bay again. It's not like the transmitter receivers of VHF or HF where single antenna is giving transmission also and receiver also. Why is this done? How are they doing it? They're not asking you to go into depth. Good for you. But why are they doing it? Simple. This is done to ensure that the touchdown with the main bogies trailing the radio altimeter reads 0. The same line that we wrote first, we make these adjustments to ensure that on touchdown, we indicate 0 on the radio altimeter. So make sure you don't miss out on this point at least. Everything else is easy. This might be ignored or taken for granted or look more complicated to you in the textbook, but it is not because I'm explaining it to you. You understand the meaning, you give a quick read and be ready for the test. I don't mind you trying the test by yourself once from the textbook itself, but don't copy. If you're doing it, first do it by yourself, check your masters, check correct or wrong, fix them and then be ready for the test also. Otherwise, it'll be too easy for you in the test. Or else you can wait for the test. I don't mind. Both ways are fine with me. Any which ways you're getting to learn. In the exams, I want you to mark correct answers. So I'm not against it. If you're doing it, then do it thoroughly. Don't do it as per the earlier method where there is a simple question error, question 19 and 20. Question is same, options are different. Nobody's able to figure it out. When I am asking you all to figure it out. So that should not happen because if that is happening, it means आपने ये सिर्फ नाम के लिए किया है और आपने कुछ और ही किया है. तो फिर 19-20 हो जाएगा. 19-20 like 69 and 70. Now nobody wants to be there, right? I'm happy with 70. I'm happy with 71. Am I happy with 69? No. Now one interesting point about radio altimeter. This interesting point is similar to angle of attack. Do you think an aircraft can have a negative angle of attack when it's on ground? Yes, many aircrafts have an angle of attack a little negative when on ground so that they get proper angle of attack when they are in takeoff positions. Similar to that, there are chances that a negative radio altimeter indication will be seen, a small negative altitude will be seen, or a negative height when the aircraft is on ground. Why is this happening? This is done so that the equipment actually is obviously adjusted to indicate 0 when the main wheels first touch the runway surface on the landing. And when the aircraft is level on the ground, the antenna will be a little below its calibrated position relative to the aircraft's landing height. And because the antenna comes a little lower because of the oleo compression and nothing else, okay, then it becomes important for us to understand that when the aircraft is on ground, a negative altimeter, radio altimeter based indication is acceptable. Not acceptable, but visible. So don't panic about it. A Boeing 747 usually indicates -8 feet on ground, is an example given to us. Simple points, but it's a new concept. You read it once more from the text. Okay. Practice. I don't think in the textbook you have questions on this. So it's very important for you to read the text carefully based upon the points we have done. Consider it to be one last revision for you when you're doing the reading task. Very simple. Whatever doubts you come across, share with me. Do not be scared in discussing doubts just because you think sir gets angry or sir tells us, oh, why this, why that. Simple question, you can answer why that happened. That will only help you in the long run. Second thing, students, whatever you need from your perspective with respect to what you know, what you don't know, what you are yet to do, not to do, keep me in the loop so that if there is something that can be taught to you in a live session, we can teach that. If there is something that you can study through a session that I already have, you can do that. Plus doubt solving, of course. Sandeep, your 1/60 doubts we will resolve, will not delay it. Everybody else is done, so I'm not going to do it in the same class unless I'm doing a revision test. Let's see. Make sure you're not forgotten anything. In case you feel it's been too long, forgotten, you want it on urgent basis, just let me know. I'll devise something for you. Over and above that, students, CP, PNR, weight and balance are the next key points for you to master in revision. So if you have not mastered pitot-static systems, do it quickly. Expect a test on basic pitot-static systems, basic air data instruments. Mach-meter theory is not supposed to be done other than V speeds. But if time permits, we can do that in short. Otherwise, if you have time, it doesn't hurt to read the mechanism once of Mach-meter also. If you have studied ASI, VSI, and altimeter. Weight and balance, the way we have done the last time is very good. We will do an exam prep session on weight and balance. Before that, be well revised. If you are not well revised, if you need some sessions, let me know. I'll remind you which sessions. You go through them once. Okay. Over and above, a few more topics that are like GPS, great circle vortices, and couple of things that are not that important but can be done will be taught to you in the live class, just like radio altimeter is. So I'm doing it with the help of Muskan. Muskan is giving me updated points with respect to lectures covered. And I'm doing it with a couple of more students also, but I'm not getting much from others. So feel free to share so that accordingly I can pick up topics and teach you all. Although Redalt was not there in a list, it was there in my list. So it helps me understand that no topic is left. Okay. Got it, students? Do this, please. And tomorrow, of course, we are meeting at the same time, 4:30. If someone is not comfortable with the time, do let me know over chat so that accordingly I'll guide you. Okay, students, will you have a test tomorrow or not? Be ready for pitot-static based tests, air data instrument based test anytime, and start your revisions with CP, PNR, and weight and balance. If you don't have notes, let me know. If you don't have anything, let me know. Sandeep, if you're wondering how and what, you just text me and I'll guide you. As rest, everybody, you have the access to lectures Z22 and F22 and Z class. From there, you can use the lectures to revise well. And always when you're revising, it will help if you keep the session played and Just increase the speed and try to find some of the other things if it makes sense. That's the whole idea of giving you recordings in the first place. So that's it. Radio altimeter is a radio-based electronic device that will give me accurate height readings from 0 to 2,500 feet based upon a frequency modulated continuous wave being radiated from the transmitter, the antenna, flush mounted horn type antenna in an conical or elliptical waveform, vertically down, straight to the ground, which is the shortest path. And the frequency as it's shot down changes at a fixed rate. Rate could be plus minus 50 megahertz, 300 times per second. Now we know that. And the received signal is varying in frequency compared to the sent signal. The frequency difference gives me the time between the sent signal and received signal, and the time difference is an indication of a height accurate within plus minus 3% of indicated height or plus minus 1 feet of the indicated height, whichever is greater in accuracy. 1 feet is greater in accuracy in that case. When I take 50 feet and there if I take 3%, still 1 feet accuracy will be greater approximately. When I take 30 feet, then probably 1 feet accuracy will be lesser compared to 0.9er in that case. So that's another mathematical example. It can measure height from 0 to 2,500 feet. Only above that, the mask will hide the pointer. The mask will also hide the pointer on multiple occasions. Failure warnings are there. Warning visual alerts are there. And so much more. Warning flag is there. Test button is there. Low altitude height reference indicator selector is there. Height indicator, of course, single pointer. The scale, we have learned about the scale also. Frequencies, UHF, SHF band, 4,400 and what, 4,600? 4,200 to 4,400 megahertz. See, only one thing I had to look for in the notes. Rest, I'm just out of memory revising the session for you in a summary. This summary that I'm doing right now, just with memory, is how I am expecting you to be with every system or every topic. You just take 30 seconds or less to talk about the entire system in such a summary. That's all it takes, students. You can revise entire nav in less than half an hour. And when you reach that point, you are the master of navigation then. But for that, your fundamentals need to be strong. Your presence of mind need to be strong. And the impact of your memory or recall of memory is nothing but based upon logical connections or mind mapping, whatever you want to call it. But you have to be invested in it. You cannot take it just, I want to do it something to start flying. No. If you do that, it will still be difficult for you. You do it because this is a part of you becoming a pilot. You do it with the same passion, as much as passion you'll have when you're flying. Only then you will get the best of it, because that's the passion I carry in every session. Do you understand the difference? We do it because it is important for every pilot to know this. If you are still not having the passion, then talk to yourself tonight in front of the mirror before going to bed. Take a good shower and think about it. Okay, is this passion that I'm missing towards this subject why I'm confused all the time? Simple. If yes, then how long does it take this recall that, sir, sahi bol rahe, ye bhi to main pilot banne ke liye kar raha hu. Done. So passion will come automatically. If it's not coming, work on it. Or just study as a good student, which you already are doing. Then that worry is not yours. But if you merge the two again, then you'll realize, wow, it's flying. Wow. So it should be effortless. But if you still think it's requiring a lot of effort, then trust me, students, struggle rahega hi hamesha. If you leave off the struggle, no subject will be complicated for you. Navigation, which seems like the most complicated subject, is the least in terms of all for us then. Remember, CP, PNR, weight and balance revision should begin. Air data instrument revision should be done. Not done, then keep revised and be ready. Today, you're going to read this. The page numbers for you to read from the instrument text. I've shared the files with everyone. We have named the textbook as NAV 3. The title is Instrumentation, and I'll give you the page number. The page number will be 250 something. 261, I guess. So page 261 to, I think, about page 264 or 5 only. 7, I guess. Yeah. If you don't have the file, request and do the needful. Finish the reading task and let me know once. You just have to read and do nothing else. Students who have missed the first part, quickly go through the first part to see question number 2, 3, 4, and 6 quickly explained. You can quickly jump and see when we are starting. We have waited for 5-7 minutes initially. So hardly 10-15 minutes you have to see. I think Suchita and Sandeep and Prerit. I'm not sure. I think y'all. Okay. Any doubts? Think. I'm sure there might be a lot of doubts, but do you have anything right now? I'm sure if there are doubts, you feel that you will read and clarify them. Nothing? Chaitanya, सब समझ आया रेडियो अल्टीमीटर जितना अपन ने डिस्कस किया है? Nukul, Sandeep, Prerit?
Affirm, sir.
Affirm, sir.
Muskan, Suchita?
Affirm, sir.
Okay. Sandeep? All good? I got your indication. Good. Okay, students, I'll take your leave. I'll see you tomorrow. And yes, that's it. I'll see you, students. Thank you very much for being a nice class. Try to be on time. If you have an issue with time, let me know. And if you are needing anything, just let me know over text. And I'll see you tomorrow, 4:30, everyone. Okay? Take care, students. Bye.
Thank you, sir.
Thank you,
Most
sir.
welcome.
Thank you, sir.
Most welcome.